Let's have a quick look at what we gotta do. Write a function find element that returns true if the element, one of the parameters, is in the list, the other parameter, and false otherwise. But we're not allowed to use the in operator. That would have made things a lot easier, but that's okay. We can do it without it. In a previous video, I actually already did this, but we're going to do it again for fun. So I've already got my script loaded up and my interpreter opened up. And, oh, we don't need that. Oh, let's ignore that. I've already got some list created here. Now we just need to make the method. So find element. So take an element and a list. I'm going to be lazy, just call it E&L. So what do we got to do? Well, so for each item in list, if I is equal to E, return true. You might be tempted to put else return false here, but that won't work because basically all you'll do if you do that is, this is what I mean. If you do this, you'll check the first element, okay? You'll get the first thing from that list, the first one. And if it is what we're looking for, we return true. And if the first thing isn't what we're looking for, we return false. That's not what we want to do. We only know if the thing we're looking for isn't in the list if we look at the whole list. So we can't say if it's not in the list unless we look at everything. So if we go through the whole list, then we can return false, because if we get to the end and we don't find it, then we know it's not in the list. So that's basically it. So let's run our script, okay? And now we can call find element, and let's look for is. Okay, I know is in the list, and we'll call some list. And true, it's in there. And let's look for something else. Best. It's in there too. Let's look for dumb. Well, it's not in that list, so we didn't find it. So obviously we went through all elements in the list and we didn't find what we're looking for, so we know it's not in that list. Now here's the interesting question about this. Now this is starting to get into real computer science. Let's talk about the best, average, and worst case scenario when we look for an item in the list. What's the best case scenario? Well, the best case scenario is if we look for James, right? So let's look for James in this list. James, we know James is in the list. It's the first thing in the list, and that's the best case scenario. How many things in our list do we have to look at? Let's assume we have a list that's arbitrarily long. I mean, we don't even know how long this list is, right? So we'll give it an arbitrary length, and we'll say that there are n elements in this list. When we look for the first thing in the list, how many of those n things do we need to look at before we found what we were looking for? Just one, just the first thing. So that's really easy. That's the best case scenario. The worst case scenario would be if the thing we're looking for is not in the list. What I mean is we need to basically put our finger on every single one of those n elements in our list before we know that the thing we were looking for is not in the list. So we had to look at all n things. So the worst case scenario, we have to look at n things. The average case scenario is, well, this one's a little bit tricky, but it's not too bad when you think about it. Basically, on average, where is that thing going to be in the list? I mean, the answer is n over 2, about like halfway through the list. That's not to say that on average, the thing that you're looking for is going to actually be in the center, but what that means is perhaps one time you look for something and it's in the first location, and then you look for something and it's in the last location. And then you look for something and it happens to be in the 5th location, and then the next time you look at it, it happens to be in the 5th last location. So on average, the thing we'll be looking for will be like in the middle, kinda. Like on average, we'll have to look at n over 2 things before we find what we're looking for. So that's the average case. So it's kind of interesting to think of how much work we're gonna have to do. Well, Pippin's coming out. On average, we'll have to do n over 2. Best case scenario, we just have to look at one thing. So it's kind of interesting to think about how much work the computer's going to have to do in like the best and worst case scenario.